Welcome to the online chemistry class at Parkland College. I'm Kim Bodie, and I hope you are excited to learn about molecules and chemical reactions and doing some laboratory experiments at home. This video is intended to introduce you to the lab kit that we will be using this semester. Our first piece of equipment is the 250 milliliter beaker. We can use beakers to hold materials or run reactions. We can use the beaker for volume measurements when knowing the approximate volume is good enough. There will be a piece of equipment for more precise volume measurements. This beaker has the milliliter values labeled at 50, 100, 150, 200, and 250 milliliter increments. There are 5 smaller divisions between each of these 50 milliliter gaps, so each small division is an increase of 10 milliliters. Using only the markings, I would be able to tell the nearest tens place value for volume. In this class, we are asking you to go one step beyond the markings and measure like a scientist by estimating the next place value. With this 250 milliliter beaker markings to the nearest tens place, we would be able to estimate the next lowest place, which would be the ones place. See how this colored water looks to fill to at least 120 milliliters? I'm going to bring my eye to the same level as the bottom of the meniscus and estimate this volume to be 123 milliliters. Someone else might estimate this volume to be 125 milliliters. Both answers would be acceptable on a lab report because both values involve proper reading of the markings and include one and only one estimated digit. Be sure to always write the unit next to your numerical answer. The unit milliliters are abbreviated with a lowercase m followed by an uppercase L. The next piece of equipment is the portable balance. We sometimes call this a scale. It is used to determine mass, just like a scale at the doctor or veterinary office. You will need to remove the balance from the box and from the protective bag. Keep the box and the protective bag for storage, since this is a delicate instrument. Place the balance on a flat surface and press the I/O key to turn the power on. As the instructions on the underside of the lid state, wait until the 0.0 is displayed. The small letter G in the upper left-hand corner of the screen indicates the measurement will be displayed in the unit grams. If you don't see the small letter G in the left-hand corner, keep pressing the M button until you have returned to the metric unit grams for this course. Sometimes an object you want to mass can sit directly on the balance and be removed easily. For example, if I want to know the mass of this pen, I can start with the zeroed out balance and place the pen on the silver portion. The display tells me 10.4 G, meaning 10.4 grams. When using digital equipment, you don't have to do any estimating of the final digit because the machine does the estimating for you. Simply record all the digits displayed along with the unit. Other times when using the balance, you may have an object that doesn't sit on the balance or is not easily removed. In this case, you will want to use a container to hold the object. Since you don't want to include the mass of the container in your measurement, we will use the T button to tear or zero out the container. Then add any solid or liquid object to the zeroed out container. The mass displayed will only be due to the item added to the container. Here I have added the sample of water that masses 116.2 grams. Remember to press the I/O key to turn off the balance when you are finished. Another item used in chemistry to measure volume is the graduated cylinder. Because the cylinder is tall and narrow, the markings are very close together, and we can record more precise volume measurements than we could with a beaker. This 50 milliliter graduated cylinder has all the tens places labeled and has 10 smaller divisions in between each label. Each smaller division is an increase by 1 milliliter. Using only the markings, we could measure to the ones place. But we need an estimated digit. Our estimated digit will be the first decimal place. I'm going to place some colored water into this graduated cylinder. Using the markings, I find that I have at least 30 milliliters. If I think the bottom of the meniscus is right on the 30, I would record 30.0 milliliters. However, I think the bottom of the meniscus is in between the 30 and the 31 milliliter markings. So I'm going to estimate this volume to be 30.5 milliliters. We use only the 0 or 5 as the final digit with graduated cylinders in this class. Transfer pipettes are used to move small amounts of liquid. Just squeeze the air out of the bulb, dip the pipette into a liquid, and then release the bulb to draw up the liquid. Very gentle pressure will allow the liquid to dispense drop by drop, but take some practice to get consistent size drops. When counting drops for a lab report, be sure to include the units drops for chemistry class, and not GGT or any other drop units. Near the end of the semester, we will use the test tubes with the screw caps. If you have both a solid and a solution in a test tube, then you can carefully pour off the solution. The transfer pipette can help you to hold back the solid. When asked to resuspend the solid, add water and stir to try to recreate a solution. In a normal laboratory setting, we would use test tubes like these and a centrifuge which spins the solutions inside the test tube at high speeds to push the heavier solid to the bottom of the tube and leave the liquid on top. In an online class, we need to be creative in coming up with ways to replace the expensive centrifuge machine. One way to mimic the centrifuge is to tape the test tubes with tightly capped lids to the sides of a washing machine. Try to balance the load by spacing multiple test tubes as evenly as possible around the inside of the washing machine. Close the lid and set the washer to the spin cycle so that you get the rotation action without using any water. Remove your test tubes once the spinning is completely finished. If you don't have access to a washing machine or nearby laundromat, you could try taping the test tubes to the top of ceiling fan blades. Use the top in case the tape is hard on the ceiling fan blade finish. Point the bottom of the test tube away from the center and make sure the lids are tight. Previous students have reported success placing the closed test tubes in a salad spinner with a lot of spinning. If you are really desperate, you could tie string to the closed test tube and spin the string and tube around your head. Do this outside to prevent damage to other people, pets, or objects. In a protective wrapper, you should find the glucose test strips along with a glucose color chart. The instructions for the test strips are on the color chart. While these test strips are sold commercially for checking urine, we will be using them to check for glucose in solutions. So just follow the directions, or dip, draw, and compare to the chart after exactly 30 seconds have passed. Model pieces are included in the lab kit to build three-dimensional models of molecules. You might need to separate the pieces if they are stuck together. The smaller pieces with the spikes represent the atoms, which can be connected to the tubes representing chemical bonds. As we learn more about combining atoms, you will find that the connections can be single, double, or triple bonds. Single bonds in the model can rotate just like single bonds would in a real molecule. When we build and compare multiple structures, we may need to rotate the single bonds or flip the entire molecule to get the view we want. You might be comparing one model to another, or you might be comparing a model to a published figure. Double bonds and triple bonds cannot be rotated with these models, just as double or triple bonds do not rotate in real life. When we build a double bond or a triple bond structure, all we can do is rotate the entire molecule in order to make comparisons to other molecules. Use a protractor to measure bond angles. We will need to set the center of the protractor on the middle atom of the bond angle and line up the 0 degrees with one of the bonds. For example, if I want to measure the bromine, carbon, hydrogen angle, I would line up the center of the protractor with the carbon atom. I could line up the 0 degrees with either the bromine or the hydrogen atom. I'll choose the white hydrogen atom. And then I'll look to see how far along the scale I need to go before reaching the remaining bond. Just like with graduated cylinders, I'll use all the markings plus one estimated digit. Because the markings on this protractor tell me the angular measurements to the ones place, I'll need to estimate the first decimal place. If my bond lies directly on a line, I'll end my measurement in 0.0 degrees. If I think the bond is between two lines, then I'll record the final digit as 5. Either answer would be considered correct as long as the markings are read correctly and one and only one digit is estimated. The units are degrees. Check your lab kit items list to be sure you have the remaining items in your kit, and contact an instructor as soon as possible if you are missing anything. Here are some further hints on being successful in lab reports. Read the lab ahead of time so you can plan your time wisely. Some labs require additional items from the grocery store. Other labs require more than one day to complete. All lab reports require you to either answer questions in complete sentences on Cobra or type a lab report to submit to a Dropbox, or do both questions and a Dropbox. When you type your data, use a table format where the data and labels go into boxes. Include the unit right next to your numerical value. Many times we provide a sample table in the lab instructions. Try to copy and paste this table so that all you need to do is enter your data and units. If you need to create a table, don't use just tabs, but instead use a table tool in your word processing program, or use a spreadsheet where you have turned on the borders to form the boxes. On most lab reports, the file formats need to be HTML, RTF, or PDF, just like the Chem Activities. To find these formats, go to the File menu, choose Save As, and look for the options that include .html, .rtf, or .pdf. You might also have the option File, then Print, then Use PDF. A quick way to find the Dropbox for the lab report is to click on the Assignments tab, then choose Dropboxes. Scroll down to find the appropriate Dropbox, as files in the incorrect Dropbox are not graded. Also, files in the incorrect format are not graded. Don't do all the work and not get credit because you have the wrong format or the wrong Dropbox. If you start the lab sooner than just before the due date, you will have time to ask questions and get help. We are here to help you, so be sure to ask. Remember that you can work with a partner from this class as long as you answer questions in your own words and you state who your partner was on the report. Have fun with these lab experiments and learn well.